In this video, we are going to solve few exponential Fourier series problems. The first problem is to find the exponential coefficients for cos square t. So we can say that given x of t is equals to cos square t, and we can use the trigonometric identities where cos square x can be written as equals to 1 plus cos 2x divided by 2. Then we can use this relationship in this equation, like x of t is equals to cos square t is equals to 1 plus cos 2t divided by 2. We can separate that 1 by 2 plus cos 2t by 2, and then we can write again 1 by 2 plus 1 by 2 cos 2t, and then we can use the Euler formula where cos 2t is equals to e raised to power minus j2t plus e raised to power j2t divided by 2. And then we can open that using this relationship. We can say that x of t is equals to 1 by 2 plus 1 by 4 is equals to e raised to power minus j2t plus e raised to power j2t. Then we can compare with the general formula of the exponential Fourier series, and then by comparing we can say that these components c of 0 which is equals to 1 by 2, so not 1, so c naught is equals to 1 by 2. The second component c2 is equals to 1 by 4, and the negative component c minus 2 is equals to 1 by 4. Second example is the DC component of trigonometric Fourier series. The DC component is the ratio of the area of the signal to the period. So, and we have already derived this formula for the DC component. A naught is equals to 1 by t, t naught a lower limit, and the upper limit is t naught plus capital T, and f of t dt. Suppose if the function is a triangular as is given by this waveform, like f of t is a triangular function which varies from minus 1 to 1, and the height of that is 2. So we know that the area of the function, because for the DC component you know that it is the ratio of the area of the signal to the period. We need to calculate the area, and if the waveform is a triangular waveform, and then the area of triangular waveform is equals to 1 by 2 length multiplied by height. So the length of this signal is 2 and the height is also 2. So 1 by 2, 2 multiplied by 2. So the answer will be 2. And second, we need to calculate the period of that signal, and you know from this waveform you can see that the period is also equals to 2. We can use this in this equation. So 2 divided by 2, the answer is 1. So the value of a naught is equals to 1. Second question is that you need to calculate the amplitude of fundamental component of this signal. So signal is given x of t is equals to 3 sine 6t plus 30 plus 4 cos 12t minus 60. And in order to solve this equation, we first need to calculate the GCD of all frequency components in this equation. So this is a frequency component, this is the amplitude, and this 30 is the phase. So the GCD can be written as GCD 6, 12, and you know the value of a GCD will be equals to 6. So this shows that 6 is the fundamental frequency, so that is omega naught. So for the second harmonics, so you need to multiply 6 with 2 omega naught. So 2 omega naught is equals to 2 multiplied by 6. So the answer is 12. So the question was that find the amplitude of fundamental component. So the fundamental component is 6t and its amplitude is 3. So that is why the amplitude of the fundamental component is equals to 3. Second question, so you need to find the amplitude of second harmonic of the signal, and signal is given x of t is equals to 5 sine 4t plus 20 plus 8 cos 12t minus 10. So for the solution, again we will do the same thing, that you need to calculate the GCD of all frequency components. So in this signal we can say that the frequency component is 40 and the other the frequency component is 12t. So we can calculate the GCD of 4, 12, which is equals to 4. So it means that the fundamental frequency is 4. So 12 is the third harmonics. Like you can say omega naught is equals to 4 and 3 omega naught is equals to 12. like 3 multiplied by 4, the answer is 12. So you can say that you can't see any second harmonic component in this signal. So that is why you can say that the amplitude of the second harmonic is 0.